Hi everyone. Here I would like to talk about this topic 17, quadratic equation, and what is quadratic equation, how can we solve it, and so what do we mean when we say, okay, this is the graph and the graph of it and those things. So before I go to that, so I like to start with these two equations. So one of them, as you can see, is y power 1 x power 1, and there is no xy in the formula, so you have y equal x over 2 minus 3, which is a line. That's a line. And the other one is x squared over 2 minus x minus 3, which is something power 2, so that's a quadratic. So I want to know what is the difference in terms of graph and those things. So I graphed both of them here. I use the software, and so you can see this here. So this guy, so is the curve here because it's x squared. So when I have a squared, then there is no line here. So that's a curve. Okay, so this is the curve, and the other one is just the line, just the green line. So the first one, x over 2 minus 3, is just the line. So this is the difference between two graphs. So when I move from power 1 x power 1 to x power 2, this is the difference between the graphs. Okay, so the graph, one of them just a straight line, one of them is the curve, which I call it parabola. So parabola, it looks like, so these kind of equations, x squared, something squared, and the same thing power 1 and a number, they look like this way. So either this way like a bowl, or either this way like a hat. So it depends on the sign and depends on many things here. Okay, so look at these red points. These red points are where the graph touches x-axis and means where y equals 0. So I can say these 3 points, which are x-intercept of the line or of the graph, these are roots of the function. So what do I mean by roots? So for example here, if I say this point, for example, if I talk about this point, means x is a number, for example, okay, that's a number, minus a, for example, if a positive, minus a negative number. And if I talk about here, so x is, oh, here I use b, yes, so x is b, and y is 0. How do I know? Because it's just on the x-axis. Okay, so for the other one as well, so x is a and y is 0. So for these 2 points I have y equals 0, so means I am finding roots of the function because the equation is 0 at these 2 points. Okay, so if I just want to show you graphically, so if I give you a line, the roots of the line is x-intercept where y equals 0. And if I give you a quadratic, which is power 2, something power 2, the same thing power 1, and you want to graph it, in most cases x, and you want to graph it, so 2 points are just maybe yes, maybe no, maybe the graph doesn't have any x-intercept, maybe the graph has just one intercept, and maybe the graph has 2 intercept. But where the graph touches x-axis, those points are even just maybe 1 point or 2 points or no points. That's roots of the function and x-intercept of the function. Okay, so let's start from a general case. This is the general case. So I don't say what is A, I don't say what is B, I don't say what is C. But then I just give you different example and I just graph them. Okay, so y equal x squared. Y equal x is just a line. You can see that's a green line. But y equal x squared is a parabola. Okay, so that's like a green one, which is like a bowl. Okay, so how about the red one? The red one, look at the negative sign. Okay, because of negative sign, when we have y equal minus 2x, that's just a red line. And when we have minus 2x squared, that's like a hat. Okay, so which is this one here. Okay, so I can show you this way. Okay, so where is it? Yeah. Okay, the last but not least is just a little bit different, and that's pink in both of them. So again, one of them is x squared and one of them x. So from x to x squared is just one power change, just one exponent change, but the graph is totally different. One of them line, one of them curve. Okay, so now solution to quadratic equations. So when we say we want to solve a quadratic equation, means we have y equals 0 and we want to find those x that make all the values that make x equal y equals 0. Okay, when we have power 2, we have either 2 points or 1 point or no point. So we don't have more than 2 points. That's a theorem. That's a theorem in mathematics. So that if I have, for example, if I have y equal x power n plus x power n minus 1, this, in most cases I have n roots. And here I have x power 2, so I have, in most cases, I have 2 roots, means 2x intercept. Okay, so let's just look at these graphs. So let's say if I just give you the graph. Okay, if I just give you the graph, you just look where the graph touches x-axis. Okay, so the graph touches x-axis here and touches x-axis here. So x equals 0, x equal 2. Both of them are the roots for this for the equation of the graph, the equation whose graph is here. And I don't know what is the equation. Okay, I just see the graph. How about here? Here is just 1 point. Just 1 point is touching and it's x equals 0. Okay, so these are, so when I make the graph, x-intercept is where x has value and y equals 0, and that's my roots that I'm looking for. Okay, so how about here? Here x equal minus 1, x equal 2, and that's yeah, this. Okay, so and here no root here. Why? Because it doesn't touch x-axis. There is no root here. So no roots here, no x-intercept. Okay, so this is by graph. So I give you the graph, you look at the graph and you can find where is the roots, where are roots. So maybe one root, the same as here, just one root. Okay, here, right, left two roots, again left two roots, and right no root. Okay, so how about if I just give you the equation? Okay, if I give you the equation, you can find the answer. But for some questions, you can find it with the knowledge that you have from past. For some question, you can find it with new knowledge that I'm going to teach you. For example, here I say what is the root. Okay, you don't have the graph, but you have this. So you say, okay, x squared equals 0. So then x equals 0. Yes, x equals 0. So 0 and 0 is x-intercept and y-intercept, and is the root of the function. So the x-intercept, y-intercept, so I can say roots, so root of x squared is x equals 0. Okay, so next, okay, how about this one here? Okay, what is the root? Okay, I told you you have to find x-intercept, means y equals 0. So you put y equals 0, you put, and then x squared minus 4 equals 0. So x squared equals 4. I know what is the answer. X is plus minus 2. Oh, perfect. I have two roots. One of them x equal 2, one of them x minus 2. And if I want to say this is, I have two x-intercept. So x-intercept is minus 2, oops, minus 2 and 0, 2 and 0. Okay, how about here? Okay, how about here? X minus 5 squared equals 0. So x minus 5 equals 0. So x equals 5. Okay, so that's that. So 5 and 0 is x-intercept. Okay, so that's the root. So the root of the function is x equals 5 here. So that's here. So how about this one? See, okay, so x plus 2 squared minus 9 equals 0. So x plus 2 squared equal 9. So x plus 2 equal plus minus 3. So x equal minus 5. Oops. Minus 5 and x equal 1. Let me see. If I put 1, it's 3 squared. Yes. If I put minus 5 plus 2 is minus 3. Yes. Yes. Okay. So I have two numbers here. So two roots. Okay. Yeah. Perfect. So how about here? Okay. So x squared plus 4 equals 0. So x squared equal minus 4. Is it possible? No. There is no real number. No real roots. So no real roots. Yes, I have two answers, but both of them are imaginary because x is oops, plus minus radical minus 4, which is plus minus radical 4 multiple minus 1, which is plus minus 2i. Okay, imaginary, yes. Imaginary set, yes. I have two answers, but I'm not talking about imaginary sets here. When I say I am looking for real roots, so no roots here. Okay, so I do not consider these. Okay, because it's not in real numbers. Okay, so now I just pay attention here and I see here I have x power 2, I don't have x. Here I have x plus 2, both of them in the bracket, and I have the number beside minus 9, so it's easy to find the roots. Here I have both of them in the bracket, so it's easy to find the root. Here again, I don't have any x, I just have s squared. Here, I don't have even a number and a x, so it's just x squared. So here is easy to find the answer. But how about if I have something else? How about if I have the same as this one? How can I find the answer here? What should I do here? Okay. So the first method is by factoring. I can factor and find the answer. Okay, so I factor here. Okay, so x squared plus x equals 0. Remember, this is not x squared plus x. It is x squared plus x equals 0. So if you don't see equals 0, don't add equals 0. So if you see just x squared plus x and you have to factor it, just factor it. But when you see equals 0, then you have to solve it. So if you don't see equals 0, don't add. If you see, don't forget. Okay, so it's here. Then can I do factoring? Yes, common factoring. X multiple x plus 1 equals 0. So x equals 0 or x plus 1 equals 0. So it is x equals 0 or x equal minus 1. Yes, I have two roots. Easy. I could do it by factoring. How about here? Okay. I can take everything one side. Yes, I do that. Then I can look for two numbers. Can I factor? Yes. And then I factor. Look at here. Yes, I factor. No, what is the answer? Okay, when I have in math, when I have a, b equals 0, I have a equals 0 or I have b equals 0. This is a theorem in math. If I have something in multiplication equals 0, either a is 0 or b is 0 or c is 0, so either of them. And it's or. I don't need to have and, because with one of them is 0, that's 0. Okay, so it's x plus 2 equals 0 or x plus 5 equals 0. So it's x equal minus 2 or x equal minus 5. So I have two roots here. Okay, so now I want to do the same thing here. So before I start to find the roots, I just did factor because for that you know it. Okay, so I factored and then I say okay, x minus 1 equals 0, x minus 9 equals 0. So it's x equal 9, x equal 9 equal 1. Done. x minus 7 equals 0 or x plus 3 equals 0. So it's x equals 7 or x equal minus 3. Okay, two roots. Okay, so maybe I can highlight them. Okay, and mathematically you have to say or, because it's impossible to have both of them. Okay, but when you say and, I have two roots, this and that, so doesn't matter, I accept. Okay, so here, and yet and in reality, yes, you have two roots. Okay, but when we want to say either this or that, so we say or, because any of them make the equation equal 0. Okay, so how about this one? Okay, I take everything one side, I factor. Look at this. For factoring part, I just don't do it because it's a practice that you did in the last lesson. Okay, so here you can factor. So one of the methods is by factoring. So 3x minus 2 equals 0. So x is 2 over 3. And 2x minus 1 equals 0. So x is 1 over 2. So x minus 1 equals 0. X is 1. 2x minus 1 equals 0. X equal 1 over 2. Okay? So remember, I'm doing it by factoring, so I'm factoring. How about here? So again, I am factoring, but at the beginning you notice, oh, I have x power 3. So what should I do here? Okay, so here that's common. I have x in common. So I can factor that and then I continue. So here I have three terms. Okay, so three brackets, I would say. Okay, so it's 2x equals 0, x equals 0. X minus 3 equals 0, x equal this. And 2x plus 1 equals 0. X equal minus that. And minus 1 over 2. And then you can do this. Okay? Yeah, perfect. So, very well. How about this question? What do you do here? Okay, you can have several methods here. First of all, I look at the question, I see, oh my goodness, I see x squared in the denominator. Okay, so method number 1. Okay, so I say 1 over x is t or w, doesn't matter. Okay, so I have 3w squared plus 2w minus 1 equals 0. Now I factor. Okay, so I'm looking for two numbers. If I multiply them, minus 3, if I add them 2. Okay, so 3w squared plus okay, first I have to find those numbers. So minus 3 when I multiply, minus 2, and let me see, minus, okay, minus 3, 3 and minus 1. 3 and minus 1, 3 and minus 1. If I multiply them, minus 3, if I add them 2, yes. So it is 3w minus w minus 1 equals 0. So it is that 3w multiple w plus 1 minus this equals 0. And w plus 1, 3w minus 1 equals 0. And w is minus 1. Okay, I do it step by step. So here, w plus 1 equals 0. So w is minus 1. But what is w? 1 over x. So 1 over x is minus 1. Then x is minus 1. Okay? Yes. So 3w minus 1 equals 0. So w is 1 over 3. So 1 over x is 1 over 3. Therefore, x is 3. Okay? This is one method. Method number 2. Method number 2. Method number 2. Okay, method number 2, I can yes, I can multiply both sides with x squared because I have denominator, I can remove it. And I am sure that's not 0. Otherwise, I have denominator equals 0 and it's undefined. Okay, that must be part of the question. Part of the question, I have to say x is not 0. Okay, otherwise it doesn't make any sense. Okay, so now I multiply. So it is 3 over x squared plus, let me see, 2 over x equal 1. So I multiply both sides with x squared. Okay, so I have 3 plus 2x equal x squared, which is x squared minus 2x minus 3 equals 0. Now I am looking for two numbers. If I multiply them minus 3, if I add them minus 2, which is minus 3 and 1, right? Yes, so now I find the answer. So it is x minus 3 multiple x plus 1. Am I right? Yeah, equals 0. And then x equal minus 1 and x equal 3. And yes, look at this. So I highlight that. So that's that and that's that. Yes, and I have to reach to the same number. Otherwise I made a mistake. Okay. Okay, so let me see if I can fix this. Yeah. Okay, so here, how about method 3? So method 3 is, I just do, where is it? So here, yeah, method 3, I just do least common denominator, method 3. So I have 3 over x squared plus 2 over x, yes, equal 1. So I use 3 plus 2x over x squared equal 1, and I have 3 plus 2x equal x squared. I find, and just I do, what do we call it, cross multiplication, and then I do x squared minus 2x plus 3 equals 0, and then I do, let me see, yes, so I just want to make sure that I didn't make any mistake. I think, okay, so 2x and yeah, 2x here. Okay, so yes, minus 3 here, minus 3. So I have the same thing here. So I have x minus 3 multiple x plus 1 equals 0, and then I have x equal 3, or so oops, x equal 3, and so x equal minus 1. So these are my roots. Okay, any of these numbers work for me. I don't need to have both of them. So if I ask you how many roots I have, yes, I have two roots, this and that. But which one makes it 0? Either this one or that one. Okay, so I have to just uh, I just have to emphasize here. Okay, so if I ask you how many roots, yes, I have two roots, this and that. But if I say which one makes it 0, either this one or this one, because one of them is enough to make it 0. Okay, so to make it just a root here. Okay, so look at these two questions. For these two questions, you have to, okay, so you have to factor. Okay, so maybe, okay, maybe that's a good idea that I do this from beginning. Okay, so I just remove it here and I do this from beginning. Okay, yeah, because these are two good questions. Okay, and yes, okay, so I make a line. Oops, I make a line here. Oops. Okay, so okay, so I keep that, and then I go to this question. Okay, so look at this. Okay, so Do you see? Okay, I see x power 4, I see x power 2. So what should I do? I notice I have 3. Oops. Okay. If it just helped me to do it. Okay. 3x s squared minus 7x squared minus 20 equals 0. So it is 3. I have one thing power 2, I have the same thing power 1, and I have a number. So this is quadratic formula, but at the beginning I didn't know. I see x power 4 and I see x power 2. So yes, that's a case. I see x power 3 and then I see x power 6. Yes, that's a case. So because I see one of them, one thing, and then a squared of that. Okay, so here I can say, okay, x squared is w. So I have 3w squared minus 7w minus 20 equals 0. Now I am looking for two numbers. If I multiply them minus 20, if I add them minus 7. I need, minus 60. Minus 60, and when I add them minus 7. Okay, so let me think. I need um, minus 60 and minus 7. So okay, I have to think. Here. Okay, so let me see. um how about if I do minus 12 and 5? What happened? Okay, so maybe I can show you here that how did I find the answer here. Okay, so yes, look at this. Okay, so look at this here. Yes, I have minus 60. Okay, so I can say I have minus 60 multiple 1. But when I add minus 60 and 1 doesn't work. I can say, okay, so I have minus, so minus 30 and 2. If I add minus 30 and 2, or 30 and minus 2, it doesn't work. How about if I have minus 20 and 3? It doesn't work. If I add minus 20 and 3, 20 and minus 3 doesn't work. How about if I do minus, okay, minus 20? How about if I do minus 15 and 4? Doesn't work. Minus 15 and 4, 15 and minus 4 doesn't work. How about if I do minus 12 and 5? Yes, minus 12 and 5. When I add them, yes, it is minus 7. So I stop here. Oopsie. Yes. Okay, look at this. Okay, so then I can say, okay, 3w squared minus 12w plus 5w minus 20 equals 0. So 3w multiple w minus 4 plus 5 multiple w minus 4 equals 0. W minus 4 multiple 3w plus 5 equals 0, and w equal 4, and w equal minus 5 over 3. Okay, so I have two roots and any of them work here. Okay, so but what is w? Listen, I cannot stop here. What is w? W is x squared. Oh, okay, x squared is 4, so I have x equal plus minus 2. X squared equal minus 5 over 3. There is no answer. No answer here. How? Because it's negative. I cannot have x squared equal a negative number. Okay, so there is no roots here. Oh, okay, so I just have two roots, which are plus minus 2 then. However, I see power 4, and based on that theorem in mathematics, I maybe have 4 roots, or maybe 3 roots, or maybe 2 roots, or maybe 1 root, or maybe no root. Okay, so here I have 2 roots. Because it's power 4, I believe maybe 4, but no, it didn't happen. I just have 2. Okay, so yes. And how about this one? Okay, so this one, I have x plus b power 2 plus x plus b minus 20 equals 0. I don't need to expand it. I show you this before. So I have something power 2, the same thing power 1. I have minus 20. So I'm looking for two numbers. If I multiply them minus 20, if I add them 1, how do I know here? Okay, so I say it's 5 and minus 4. Okay, so it is x plus b x plus b plus 5 multiple x plus b minus 4. Okay, so x plus b plus 5 equals 0, x plus b minus 4 equals 0. So x equal minus b minus 5. I don't know what is b, but doesn't matter. I still can find x. But x is based on b. I need to know b, but doesn't matter. Here, what is x? 4 minus b. Done. I have two roots. Okay? Two roots. And any of these roots make my equation equal 0. Okay, how do I find the roots? Did I do it did I do it by graphing? No, I don't have the graph. Did I do it by easy equation? No, I didn't have like the previous pages. So what did I do? I factored. The first method is factoring. You factor after graphing that you don't have. So this is the first method you do by factoring. Okay, so here find a quadratic equation in this form that has roots equal 4 and minus 6. I can say and, it's okay because I have two roots, but any of them make my equation equal 0. So that's why I say or there when I find equal 0. So here, this is my root. Okay, how can I find the equation? Oh, okay, so I can go backward. How? Okay, x equal 4, x equal minus 6. Therefore, x minus 4 equals 0, x plus 6 equals 0. Oh, perfect. Now I multiply them. Now I am going backward. Okay, so I have x squared. Okay, my handwriting awful, I know. So plus 2x minus 24 equals 0. So A is 1, B is 2, and C is minus 24. Oops, very good. Okay, now I stop here because this is the first so this is just the first method, so that's video 1. I stop, and for the other one so for the rest I make another video or maybe videos. Okay, so it depends. Thank you so much for your time. Bye.